So there is the community edition of Docker and the enterprise edition of Docker, which I have explained you already. Right. And there are timely releases. Community edition Edge released every month. Community edition stable released once in 3 months or quarterly along with the patches as needed. Enterprise edition is released every 6 months or twice a year along with the patches as needed. So Docker is basically a technology developed using the many different Linux kernel features, such as C groups for the resource control, how much of resources a containers can consume. Namespaces is for the isolation. There are many namespaces that gets created for each container that we create. The IPC namespace for interprocess communication isolation, network namespace, PID namespace, name namespace. There are many different namespaces that gets automatically created when you create a container using a Docker command. There are capabilities of the host operating system or the kernel exposed to the container, and what capabilities to be exposed. There are some default, but if you want to expose more, you also can do that. One of the option that you can use is dash dash privileged while creating the container if you want to expose the additional capabilities to the Linux, the container that you create. There is SLNX, Netlink, NetFilter, AppArmor for the security between the containers running on the same engine. There were many libraries which were used earlier, such as LXC, libvirt. Now Docker settled with its own library, libcontainer. Whenever you run the Docker commands, it is the libcontainer which talks to this Linux kernel features to create a container and get the C group created, namespaces created, and capabilities exposed. All that is taken care by the libcontainer library used by the Docker. If you have large number of containers to manage, it's not easy to work with the standalone Docker engine. What if the engine goes down? What if the OS goes down? What if the kernel is corrupt? What happens to our application? Which is where you should think of the tools like Docker Swarm, Kubernetes, Rancher, OpenShift. There are many more tools available. That was the introduction lecture that I had. So let me bring you the next lecture that I generally cover before we jump into the next demonstration. So we will understand what are the hardware and software requirements. Wait, in the wrong slide. So before the break, I was trying to talk about some of the Kubernetes details. So which is where I landed up. So hardware and software requirements for Docker to be installed. How do we install the Docker on Linux? How do we manage the container lifecycle? We had the demonstration on that. You can have any flavor of Linux with minimum kernel version 3.10, or you can have Docker installed on Windows Server 2019, just enabling the feature. Or if you have Windows 10 or previous version, you will need to have some virtualization software like a Hyper-V. You can also have Docker installed on any cloud instance. When it comes to hardware, as long as you can have the operating system installed, you're good to go to play around with Docker. How many containers you can run depends on how much of hardware resources you have. You can install Docker, which is a distribution supplied version, or packages that are supplied by the Docker. I demonstrated using the packages that were supplied by the Docker. We installed the Docker Community Edition. There's also scripts available. Running those scripts will install the Docker automatically. We did install the Docker. We enabled and started the Docker. We did not got into more details once after the installation of Docker. If you want to know more details of the Docker that you are currently installed, you just can run the command docker info that give you a lot of information, such as the client details, the server details. In server, there are how many containers total, how many running paths stopped, how many images are there, Docker engine version, which storage driver are you using, which logging driver are you using, cgroup driver, and the plugins that are loaded for the volume network for logs. Is the Docker Swarm active? What is the runtime you are using? So there's a lot of information, even about your operating system. What is the kernel version you have? Operating system, OS type, architecture, how many CPUs, memory, name of the server, and the server ID, and where is the Docker related database maintained? The data Docker root directory. What is the default registry from where the images are pulled and where the images are pushed? This is the URL of the Docker Hub. This is how Docker know from where the images to be pulled, and this can be changed. Before I get into how to change some of the configuration, let me cd into the directory. This directory is where Docker maintains the database about the containers that you have created, the images that you have pulled, the networks that you have created, the plugins that you have loaded, the volumes that you have created, the runtimes that you have. All that information goes under varlib Docker. Right. Now there is also one of the configuration file that you can create, /etc/docker/ daemon.json, which does not exist by default. In this, you can have custom configuration. What if I work for an organization and I don't want Docker to go and pull the images from the Docker Hub? Instead, we want the images to be pulled from the internal registry of our organization. Is that something doable? Yeah. How is that we can do? So we can stop the Docker daemon for a while, create a configuration file under /etc/docker with the name daemon.json, and provide the details of your registry. If it does not support the TLS, then you can also have an option insecure registry, and then start the daemon back. So whenever the image is to be pulled, it will pull from the internal, whatever the specified registry instead of Docker Hub. This is how you permanently change the registry source from where the image is to be pulled. Otherwise, if you temporarily want to pull an image from some custom source, you just can say Docker image pull, and then maybe https://some server slash maybe CentOS/7. You can pull like this also, CentOS:7, for example. You can point Docker to pull the image from a specific URL as well. If you just put CentOS:7, where is it going to go to? Docker Hub. How does Docker know where to pull the image from? Docker info has that information. How can I change this behavior permanently? That's where you need to use the custom configuration file, varlib, /et/docker/daemon.json. Just like this sample, you can copy and paste in there the entry. So now Docker will look for this registry instead of Docker Hub, is how you can do it. And then by default, Docker refers to varlib Docker for the database to maintain. Can I change that path? Of course, stop the daemon, edit the daemon.json, provide the custom path, data-root, then the custom path from where you want to write. So this daemon.json file can be edited. There are a lot of custom configuration that you can do it by editing the daemon.json. So we also learned how to expose a container, where is the database maintained by the Docker, and we learned how to install the Docker. We also learned how to manage the lifecycle of the container. Docker space container to manage the containers, Docker space image to manage the images, Docker space network is to manage the networks, Docker space volume is to manage the volumes. We currently learned only Docker space container command. Now we're going to explore the image specific commands now. Let's get into image management. All right. So let me get you the demonstration how we can manage the images. First of all, how do we list out the images? We can run the command docker space image dash ls. Before we get into the subcommands of the image, let's take the help. We can list the images, we can pull the images, we can push the images, we can clean up unused images, we can remove a specific image, we can save an image as a tarball, we can load an image from the tarball, we can import a container state from a tarball, we can check the history of an image, the changes and the layers in the image, we can build an image, we can tag an image, we can inspect the details of an image. So this is what we are going to do now for the image management. I'm going to demonstrate an example for each of these subcommand. But for your knowledge, each subcommand also has an options, which I may not be able to get into due to the time limitation, which I'm sure you'll explore on your own. So how do we list out the images? Docker space, image space, ls. How do we search for an image? Docker search and the name of the image that you're searching for. It's just the search criteria. It need not to be exactly the name of an image. So there are a lot of search results. I want to filter this result into what I'm really looking for. So let me go to Docker Hub and search for the same image Alpine. There are many different images. Okay, there are basically three types of images. One, official image. Second, verified images. Third, user images. I, as a Naushad, can also build one image and push one to the Docker Hub to be accessed, but only by me, making the repository private, or by default public so anyone can access or pull that image. Again, here, click on official images, right? I can filter my result if I wanted to. There's also at the right hand side, there are stars, meaning click on that image. There is the star icon available. If for some reason I used this image and I'm happy to recommend others, or I want to appreciate by putting a star, is how is what the number of stars are. Now, what if I want to filter the image list based on the stars? I just can run the command docker image search for the Alpine. Additionally, I can type in dash dash filter is equal to based on stars, any image having at least 100 or more number of stars. Filter dash dash filter stars is the typo. Sorry about that. As you can see, only the images which having at least of 100 or more stars is what is being listed. So there are more options available for you. It's just not filters based baby is official. So like that you can have more filter options to be used. -F can be used or -- filter can be used. Okay, so how do we pull an image? Docker image pull, name of the image that you want to pull, such as Alpine. So it is using the default tag latest to pull an image. It is pulling from the official, it is pulling an official image, right? Now, what if I want to pull a user image, right? So in the list, I have an image called Alpine Git, right? So if you just say Alpine, it's going to be an official. But if you want some user or verified image, you can say you just have to provide the complete path, right? So for the same, I can pull an Alpine /git. Actually, it is docker.io is the site /Alpine is the repository from where we pulling the image. Docker.io is the registry. The format of this path what I've given is registry / repository / tag image, actually image and then the tag. Default is going to be latest. So it's pulling that image. So how do we list out the images? Docker image ls. We have 2 images now. And Alpine is the smallest image among any other image. It's just about 5 MB. Now, how do I know more details about the image? Just like you do a Docker container inspect, you also can do Docker image inspect and the name of the image. You should be able to get the details of the image. There's a lot of information that you might be interested in doing the inspect of an image to understand how was that image built, what is part of the image and stuff like that. Meaning like a port, like what command getting executed by default. All of that information can be gathered from the inspect command. Docker image inspect and the name of the image. All right, so there may be also scenario where some of the servers are not directly connected to the internet, right? How will they be able to pull an image from the external sources? The only choice you have is get connected to one of the server which has the access to internet, pull an image and save the image as a tarball. For example, Docker image save, name of the image, then -o is to say output. Just name it something like Alpine backup dot tar. Sorry. This tarball can be shared either via email, via the shared drive or something to the server which does not have access to the internet, which is the use case of why you want to save an image as a tarball. Okay. Let's try to list out the contents of this tarball. Tar space dash tvf and the name of the tarball. There you go. So this is what there inside the image. So let's do one thing. Let's remove the local copy of image that we have, the Alpine Docker image RM and the name of the image. Now assume you are the person who actually received the tarball. How will you use this tarball? You will have to run the command docker image load -- input. If you don't remember things, don't bother. You just can run the command help docker image load dash dash help. So it has an option dash dash input or dash I. Try to learn and try to take advantage of Linux help. And the tarball that you have from which you want to load an image. Save, load. Now, if you run the command docker image ls, you have an image. So we just learned how to different ways to get an image. One easiest way is pull from Docker Hub. That's a very easiest method. Second method is use the pull the image to one of the server which has the internet access. Save it as a tarball and load it on the server which does not have access to the internet. Save, load. Right. I'll keep updating these notes to help you understand different ways to get an image. You also can take a look at there are how many layers in the image. Run the command docker image history and the name of the image. These are the layers which has made the Alpine image. Let me check the layers of Alpine Git image. There must be more layers because the Alpine Git is on top of Alpine image, right? So yeah. Now let's go ahead and learn another method of getting an image. Let me teach you how you can commit the state of one of the container as an image. So let's go ahead and create one CentOS based container, Docker container run with the name server01 detached interactive terminal using an image CentOS. So I'm teaching you now, can we capture the state of one of the container as an image? Meaning we're learning how to commit a container state as an image. So let's get inside the container, Docker container attach, and the name of the container. I have only one container named server01. And let's try to install the nginx, for example. How do we install? Yum install -y nginx. So we created a container of using a CentOS operating system image. Inside the container, we installing the nginx. It's taking a little longer than expected. Sorry about that. It's trying to check the repositories, the package repositories, not the image repositories, the OS packages repositories to install the nginx RPM package. So once after the package get installed, just to identify some more differences, I will create one extra file with some few lines inside the file. I'm trying to borrow some more time as my system borrowing time. to install this nginx. Today I'm experiencing little bandwidth issue. Otherwise, this should get through very quickly. It is dealing in KBs. What a good sign. I'm happy you're still hanging there. So by the time I see there's one question in the chat message, we can either have an image pulled or create a container, then create an image out of it. Yeah, you can create a custom image or you can use some standard image available from external sources like a Docker Hub. That's correct, Subha. So finally, the package is getting installed. Some more packages. Let me quickly switch to a different network if that can help me speed up. Yeah, I switched to a different network. That's why you see those color errors, but good to see things are going a little faster. I could have done that before. Okay, yeah, we're good. Then I will also create a file, maybe Naushad file under slash. Anyways, we are in the slash. There you go. So we made two changes. One, we created one ASCII file and we installed a package for nginx. Let's come out of the container. But this container state is what? It is an nginx container because we have the nginx package installed. We could have started the daemon. We could have tested the nginx is accessible. I'm keeping it simple now. So Docker container ls confirms you have a container named server01. Let's try to capture or commit the state of this container as an image, right? So let's run the command docker container commit, name of the container, and what should be the name of the image after you have committed this. Okay, I just call it as CentOS colon nginx dash nau 01 naushad 01, something like that. So if I now check docker image ls, I have a new image named CentOS nginx dash nau 01. We just created about 5 seconds ago, right? Is that means container is not there? No, you will have a container still up and running. So you just learned that a container state can be used to build an image or to commit the state of a container as an image, right? So now you can create a new container. Let's go ahead and do that. Docker container run with the name. Let's call it as server02 -dat and then the image. We want to use the new image that we have just got from the commit process. There you go. Docker container run with the name server02 -d for detached interactive terminal and the new image that we have just captured. Right. Docker container ls should show that server02 there. Let's get inside the container. Docker container attach and then name of the container server02, and then I will have to ask for the shell to be presented. It requires you say Docker container attach and the name of the container. So yeah, I'm sorry about that. I don't need to have the shell because it's just already an operating system image. Let's run the command ls. You have the nowshot file. Let's get the content of that file. Also verify you have the package nginx installed already. So these are the two changes that we made, which we can see already. Any container that you create from this image will have those changes. This is like you creating a template or you creating a golden image, which is what you call it in the virtualization world, right? Okay, how do I know what differences or what changes we made inside the server 01? We also can run the command docker container not diff difference for the server 01. A lot of differences that were made. Let's try to grep for NAU. That's my name. This file has been added. A means added, C means changed, D means deleted. So you can easily find the differences. What is these differences between? It is the differences between the changes that you made inside the container and the image that you used for creating this container. Meaning differences between the CentOS image and the container server 01 is what you are able to see. It's a container difference. It is cross-checking with what? Current state of the container and the state of the image itself. So these are the few changes that it has seen. All these changes are maybe due to the nginx that you installed, right? So it has made a lot of changes inside the container. So these changes are maintained where? In the right layer of the container. Every container is given a writable layer. And this writable layer gets automatically deleted when the container is deleted. That's about how you commit a state of a container. So we just learned the next possible way, right? So we learned how to commit. Maybe I change the switch to a different network. So I have this error. I just had to ask for force connect. We learned how to commit a container state. I will explain you the next method. We can also export and import a container state. I'll also explain you the difference between the commit and the export. So Docker container export, name of the container. Let's export the server 01. Earlier we did the commit. Now we want to do the export. But what are the options available? Let's ask for the options. So you just actually have to provide the name of the container and then redirect that to a tarball. For example, server01 underscore um, state dot tar kind of ls dash lh. I have the tarball. Now commit give you the image, whereas export give you a tarball. If you want an image to be pushed to the Docker Hub, go with the commit method. If you want to share the state with your colleague, from what is the advantage? Your colleague can import this tarball as an image, create a container out of it, and continue from the point where you have stopped your work, because you both of you work for the same project. Maybe you worked from morning 9 to 5, and your colleague may continue from 6 to 4 a.m., something like that. So if you want, what is another difference between the commit and the export? Commit depends on the base image from which the container was created. Commit depends on the base image using which the container was created, which means the base image plus the differences. Whereas export is going to be a single image, meaning complete image, meaning it is to have a single layer, meaning combine layers into a single image. Export is the option. Another reason why you want to export is you want to make it available to your colleague as a tarball instead of an image. Right, so we have it exported. What will my colleague do having that tarball, right? So let's try to import this tarball. But you cannot import as a container. You'll have to import as an image, Docker image import, the tarball name what you have, and then what should be the name of the image, CentOS colon NAU02, for example. Now, when you run the command Docker image ls, you will have a new image imported, CentOS NAU02, right? It is an independent image. Now, what I mean is, if you cannot remove this CentOS image because this is dependent on that. But this imported image is not dependent on that CentOS base image. Independent is one of the difference, right? Don't go on the size. This size refers to the base image plus the differences. Don't go on the size. Okay. All right, so we just learned how to export and import an image, a container state as an image. How do we remove the images? Docker image rm and the image that you want to remove. This image was not used by any container, so we could just remove it. Now, if you try to remove the CentOS, it might throw you an error as it's been used. Can I still go ahead and force it? You can, but image has not been removed. Only the tag named CentOS is been removed. Still, the image is consuming disk space. It's not showing you here because the tag is removed, untagged, but it is still consuming the disk space. And Docker will not be able to identify that image, meaning Docker will not be able to list that image, but practically the image still there on the file system. So it is just got untagged. The image is not been technically removed. Tag is just extra name. you can have multiple tags to a single image. Like we have this particular is another name for this image, right? So just like that. What if I want to clean up some unused images? Docker image prune -f to force. It did not remove any, as all of these are needed, right? So this is some of the fundamentals that you need to know for the image management. But now there are a few more things that I want to explain. Docker image ls. How can I push this image to a Docker hub? Let me demonstrate that. Let me get connected to Docker hub. I've already logged in with the login ID as on cloud. If you don't have an account with Docker hub, you'll have to sign up and you just have to log in. And I have multiple repositories already, right? The first thing you'll have to do is you have to log into your system. Docker login. Which credentials to provide? The Docker hub credentials. Whatever the login name and the password. So it logged you into the Docker hub. Hoping. There you go. So it also warns you that your password is stored in this. Right? This is your authentication token. But once you log out, this will get automatically removed. Let me show you that. Docker log out. Now there won't be authentication token. So let me log in back again. So let me list out the images that I have currently on my engine. And let me try to push Docker image push. And the image that I want to push, it will fail because by default, it will try to push to the official library of the Docker Hub registry, which we don't have an access to. So you see it's pulling to official library. We don't have rights or authorization to push it to official. So how do we push then? We should tell Docker to push it to our repository for the login ID is on cloud. But we'll have to tag an image before that. So we'll have to run the command docker image tag same image what we want to tag and our login ID is on cloud in my case colon the name of the image. So extra information we added to the image is our login ID in the to the Docker Hub account. No, I missed something. It's supposed to be slash. I'm sorry about that. Login ID slash the image. Now when I run the command docker image ls, I have a new tag called eyes on cloud slash CentOS and then this. I can push this image now. Docker image push name of the image along with the tag. So now while pushing the image, Docker understands, hey, use the login ID eyes on cloud to the Docker hub and push it to that ID. You see that? Instead of going to the official library, it's going to the eyes on cloud. So this is one of the reason why you want to tag an image. You're helping to which repository in the registry you want to push an image. You must have a valid account on Docker Hub. So it understands there are a couple of layers already exist. because I've pushed many images. For some reason, handshake timed out. Let me try again. And also I want to verify if there is an image already by that name, NA01. I keep doing or having such names. See all. I don't. Yeah, it's successfully pushed. Let's verify now. So let me go to repositories. Let me go to CentOS. And there is, no, I don't see. A few seconds ago, there you go. nginx/nau01. So I've successfully pushed an image. How do you pull an image? This is what you have to use the tag name if I were to pull an image. So registry is a central repository to which we can push an image, from which we can pull an image. So I just demonstrated how you can push and pull the images from the Docker Hub. Right. Now let's do the cleanup. So these are the few information that you want to know when it comes to working with the images. The next thing I want to explain you is how do you build your own image, right? Let me explain that. Let me make a directory called example, seed into the directory. Now I'll explain you each of the directive that I will use within the Docker file. Now pay very close attention. PAM Docker file. This is the name what we're supposed to give. We can give something else also as the name, but extra option -F to be supplied while building an image. To avoid, go with the default name. Dockerfile D should be capital. Linux is case sensitive. The very first line that you want to have is from. What should be the base image using which you want to build this image, right? If you're not familiar with what should be inside the Docker file, like I already recommended you, search for an image like nginx, select the image, pick one of the version, doesn't matter which version you pick. It redirects you to GitHub and it will take you directly to Docker file. And the very first line that is from. It should be the first line from. There may be also cases where the very first line can be scratch. For example, if you search for an image, hello world, it just prints a hello world message, right? It doesn't need any base image, you see, from scratch. Copy the file hello from the current directory inside the container and run the command /hello, which is a script, right? If you don't really have any OS dependencies, then you don't need to reference any base image, meaning Docker image can be, it is independent of a base image. That is also possible. One of you asked me question before the lunch break, right? So let's take this example. Let's go to GitHub and to the Docker file as an example for us. So very first line must be from. It can refer to one of the base image or can refer to scratch. And the very next second line can be optionally a label, which is for a metadata, such as what if somebody want to reach out to you for any questions, queries, or any bugs that they have found, or they want to take your help for something. So you can put the label maintainer. There can be multiple values. That's the label. And then you can have multiple environment variables. What if somebody use this image and the application expect some of the environment variables? Can we hard code that as part of the container image? You can do that. If you log in inside the container and run the command echo dollar nginx underscore version, it will print the version, which is one of the environment. You can have multiple environments. And what if I want to execute a command inside that container? Use the run command. For example, run yum update -y, and then run a command to install nginx package. So I'm preparing an nginx based container image. Okay, you can have multiple run commands, but each step or each instruction in this Docker file is going to make one layer. So recommendation is to avoid or combine multiple run commands together to reduce the number of layers. How can we do that? Use the Linux shell feature $& and run a couple of commands. Instead of 2 lines, which is 2 layers, I can just have 1 line, which is to reduce the number of layers, because each line instruction in this Docker file is a layer. So that's a smart work. Even nginx image is built how, right? You see there is many $. This could have been 100 run commands, which means 100 layers. But these layers are combined into a single layer using the $. This is the recommendation, best practice to follow, right? That doesn't really impact on the performance when you have multiple layers. But just imagine you have split your image into hundreds of layers. We understand, having splitting a single file into multiple files is not something what we do. Otherwise, there's no real side effect of having multiple layers. It's just little unnoticed performance issue, right? Then what if we have some files from the engine to be copied over to the container? You can use the copy command, right? You're saying, hey, on my current directory, I have a docker-nt point.sh, copy that inside the container to the slash, right? And what if I have a tarball instead of a regular file, right? That's where you have to use add command. For example, there's a tarball which has multiple files. You want to extract the files of the tarball inside one of the directory. You can use add command. Otherwise, add is similar to what copy does, copying files from source to destination, but copy cannot untar. And copy cannot support the HTTP kind of a URL. For example, you have a web server from which you want to, copy the file, is not supported by copy. Copy just does the basic thing. Copy a file from the local system inside the container. Add does the same. Additionally, add can untar and add can accept the URL as a source. Is something that you want to understand. People generally ask, what's the difference between copy and the add command? Now comes the entry point. Now, what if you want to run the scripts inside the container when the container is started? So you can call the script using the entry point. Here where you copied the script and now you're running the script. The script can get executed inside the container when the container is created from this image. There's also CMD. People mostly get confused between the entry point and the CMD. So when I create a container from this image, I want the nginx daemon to be running in the foreground. Daemon off, daemon by default is background. You want the daemon to be running in the foreground so that your nginx service is running, right? You can also call, the command argument using the entry point. One of the difference that I can tell you is when you have some executable, you generally use entry point. When you have some daemon-like actions to be taken or some commands to be executed when the container starts, the very first command get executed is cmd. All right. There's a lot of differences that you want to know between the entry point and cmd. I'm sure you'll spend some time knowing the differences between the entry point and cmd. Due to time limitation, I will not be able to talk much. You can also have your container listening on specific port by having the expose as the instruction inside the Docker file. Maybe you want to put TCP, and you can have multiple ports to be exposed. Maybe 80 also, and 80 also is also something doable. One of the best thing I can explain is you want HTTP traffic and you also want the HTTPS traffic, for example, 443, like this, right? And hey, Naushad, is there an order to follow which should be first instruction, which should be the next instruction? The from should be the very first instruction. Immediately after that, you can have label optionally. And the rest of the instructions doesn't matter in which order you follow. Generally, there are few of the recommendation. Something that you frequently change should be at the top so that the corresponding layers are rebuilt is one of the recommendation, is how you want to consider. There are best practices. I'm sure you'll spend some time looking at what are the best practices while building the images. I've just covered very limited information due to the time limitation, but there are many best practices to consider. So these are some of the instructions that you can have within the Docker file. Let me remove some of that which I don't need. I just add it for explaining. And now let me go ahead and instead of this, I would want to copy my index.html file, for example. Under usr share ng inx/html. That's the default location that nginx looks for serving the web pages. Let's go ahead and save it. So we have Docker file, but we don't have the index.html, which is a dependency. So we have all the supporting files. How do you build an image? Docker image build -t, the tag, for example, CentOS -v1 or nginx v001. Creating these images, so I don't remember. I should follow some format. Then to be able to build this image, where are the supporting files? Dot, meaning the supporting files are in the current directory. Docker image build -t is a tag. If you don't give a tag, it will have a random container ID generated. Sorry, image ID generated. So it's running the steps. This might take a little longer. We run the step number 4. As you can see, each step is a layer, as you can notice. I will explain you the advantages of these layers. I'm sorry about that. I will interrupt it and then remove the update step to speed up. repo list. Let's try it again. Okay, looks like I have some error. What is that? Command name install. Okay. Yeah, I should be giving -y. So you can easily identify the error, make a necessary change and rerun it. It's not going to cause anything. It will continue from where it has stopped. So you see using cache. So Docker by default caches the layers to be reused when you build an image. Maybe this is the engine on which you mostly build an images, and cache can help speed up the process of building images if there are layers already in the cache. If you wish to skip using the cache instead, build a new layer also possible, supplying an option. I think -- no cache or something during the build. But otherwise, by default, it uses the cache. I'm not sure why today my internet speed is slow. Otherwise, I have the good line. It's taking a little longer. Yeah, so the image is built. Let's verify Docker image ls. So we just learned how to build an image. The name that we gave is nginx01 v001. All right, let's go ahead and create a container out of it. Docker container run with the name web01 -dat, name of the image. Docker container inspect. Let's try to identify the IP address web01, and let's capture the IP address of the container and try to do a curl to see is it serving the custom web page that we wanted it to serve. There you go. Yeah, so you also learned and images can be built using the Docker file. So these are the different ways how you can build an image. You can pull an image from the Docker Hub or any registry. You can save an image as a tarball and load it. You can commit the state of a container as an image. You can export the state of a container as a tarball and import the tarball as an image. Or you can build an image using a Docker file. Actually speaking, what do we do in commit? We create a container. We make the necessary changes and we commit the state of the container. Actually is what we are doing in the Docker file also. You know what happens behind the scene? A container gets created using an image CentOS. Inside that container, these commands get executed. These commands get executed. And it commits the state of the container, which has all of this executed as a new image with the tag that you gave. But then what is the difference between Docker container commit and the Docker image build? What do you think the difference is? Docker container commit is the manual process of getting an image, whereas Docker image build is the automated process of building an image. Which one is recommended? Is to go with the Docker container commit or Docker image build? I'm sure you have the answer, Docker image build, because you always have this file for your reference. And these files can be also versions can be controlled, maybe having this file in a GitHub, make minor changes, and then as in when you're developing, make the changes and then maintain multiple versions of that file. You always have a file where you can track what changes have you made. So Docker image build method is something which is recommended. Otherwise, Docker container commit, Docker image build, behind the scene, it is same, almost same. What I'm going to do now is stop the recording